Hello and welcome back. For this video, we're going to talk about operations with radical expressions. And we can see what our goals are here. We want to add, subtract radical expressions, and we want to multiply radical expressions. And radical expressions are just those expressions that have radical signs in them, like square roots. All right, so one thing you might want to write down into your foldable is when you're adding or subtracting radicals, you want to treat the radical component as if it were a variable, because you can add like variables and you can add like radicals. For example, over here, if I have 5a plus 3a, we know the answer is going to end up being 8a, but the reason for that is we have a common a that factors outside so that we can then add the 5 and the 3 together to get the 8 and then times it back by the a. We can do the same thing with subtraction, so these have a common b, so you factor the b out. Now you can do 7 minus 2 and get the 5 and multiply it back with the b. When we do radical expressions, it's exactly the same. We've got a radical 3 and a radical 3, which makes them like terms. So we factor that radical 3 out, so we can now add the 5 and 3 and get 8 radical 3. And likewise down here for subtraction, we take the radical 5 outside, we factor it out, then we have 7 minus 2 inside, and we just multiply it back by the radical 5. So you don't actually add or subtract the radicals themselves, you treat them like variables. All right, for this example, we're going to talk about add and subtract the expressions with like radicands. And radicands, again, are the numbers that are under the radicals here. And you can see that we have two sets of radicals, radicands, so we got 5s and 7s. So what I'm going to do is going to rewrite this using the commutative property. So I'm going to bring the 4 square root of 5 and the negative 2 square root of 5 up front. So I brought those two up front. Then I'm going to bring down the plus 3 square root of 7 plus 7 square root of 7. So I'm going to add these two together and add these together. Now remember, when these have like radicands here, that means all we're doing is 4 minus the 2. And that will give us a 2, and the radical 5 just comes along for the ride. So it's like I had a 4b minus a 2b there, and I get a 2b left over. Then I got my plus, and then over here I've got like radicands again, which is a root 7. So I end up with a 3 plus the 7, which is a positive 10, and I keep the like radicand of 7. Now, since these two are not alike, I can't go any further with my simplification. Therefore, my solution would be 2 square root of 5 plus 10 square root of 7. Okay, for our next example, we want to add and subtract again, but expressions with unlike radicands. So you'll see none of our radicands are the same. So anytime that happens, the first thing you want to try and do is simplify the radicand, or simplify the radical, and then see if any of them are alike. So I'm going to go ahead and put the 3 over here, and the 75, the square root of 75, can be broken into the square root of 25 times the square root of 3. So you should be good enough at this now to look at the 75 and realize, oh, its largest perfect square factor is 25, so we broke that out. So if I multiply those together, I get the 75 back, so I know I did it right. And then I'm going to reduce this 3 times, and the square root of 25 is 5, and the radical 3 comes down. Then I multiply these two together, and I get 15 radical 3. Now I'm going to do the same thing over here with my negative 6 and the square root of 48. So I'm going to bring my negative and 6 down. And the square root of 48, you should recognize it as the square root of 16 times the square root of 3, and 16 is the perfect square that fits in there. So bring down my negative 6 times, and the square root of 16 is 4 times the square root of 3. When I multiply these two together, I get a negative 24, and the radical 3 just comes along. Now, if you can't figure out what the largest perfect square is, like I did with the 16 and the 25, you could always do prime factorization of 75 and 48. That's the long way around, but it does work. And then over here, I have a negative 27, negative square root of 27, which happens to be a square root of 9 times a square root of 3, because 9 is a perfect square. So I can call that negative 3 square root of 3, and I'm just going to bring that down with my minus 3 square root of 3. As it turns out, you can see all three of these have a common radical 3. So we could factor all three of them out and call it 15 minus 24 minus 3. I factor that radical 3 on the outside, and then I just combine these in the middle together. So 15 minus 24 is going to give us negative 9. And then negative 9 minus the 3 is going to give us a negative 12. So we have a negative 12 radical 3 is our final simplified solution. Okay, so what we're about to do now is multiply radicals. So we have to have a little bit of a prior knowledge here. So looking at our monomials here, we have 5x times the 3x. Now that's the same thing as bringing the 5 and the 3 out and multiplying them together and the x's together and multiplying them. And then we finally get 3 times 5, which is 15, and x times x. Remember the rule is there to add the exponent, gives us x to the second. We can do exactly the same thing with radical expressions. So these two numbers out in front, 3, those are called rational numbers. And you can multiply rational numbers together, so that's what we're doing. We're bringing them together here. And the two that are underneath the radical here are called irrational, so we're going to pull them out here and multiply them together as well. When we multiply 5 and 3, we obviously get 15. What happens when we multiply square root of x times the square root of x? Well, what happens is we get square root of x raised to the second power. And remember, a power 2 is going to undo a radical just like a radical undoes a power 2. So the only thing that comes out of it is an x, so we end up with just 15x. So in this example here, we're going to multiply radical expressions. So we're going to rewrite it as 5 times 4, because those are the rational components, times, and I've got a radical 3 times a radical 6. Those are the irrational components. So I'll multiply them together, so I end up with a 20 out in front. And under the radical, I have an 18, so radical 18. Now you can't leave your answer like this because the 18 has perfect square factors in it. So I'm going to rewrite the square root of 18 as the square root of 9 times the square root of 2, because that still gives me the 18. But the 9 here happens to be a perfect square, so when I simplify that, so when I bring my 20 down, I'm going to put a times symbol here, because I'm about to simplify the radical 9, which comes out to 3. I still have a radical 2 there, and I'll just multiply those together, because now that 9, which appeared to be irrational, is actually the rational number 3. So I have 20 times 3, which is 60, radical 2, and this is our simplified answer. Okay, for the last example, we're going to show how to multiply radical expressions using the distributive property. We've got the 4 root 7. We're going to distribute to the 2 root 8 and 3 root 7. So when we do that, we take the rational part and multiply it with the rational part. So 4 times 2 is going to give us the 8. And then the irrational part with the irrational part. So root 7 times root 8 is root 56. Bring down the plus, and I'm going to take the 4 and distribute to the 3 over here. That's going to give us the 12. And then the radical 7 times radical 7 is going to give us radical 7 squared. And radical 7 squared is actually a perfect square. Remember that the power 2 is going to undo the radical or the square root. And that's going to give us a times 7. And then when we simplify that, we end up with an 84. Bring down the 8 square root of 56. Now this is close to being done. The first thing we want to do is we want to bring that 84 up in front. So 84 plus 8 root 56. Now we still have to abide by the rules of simplifying radicals, which means we have to take all perfect square factors out. So this 56, the square root of 56, is actually 7 times 8. And the 8 is, of course, 4 times 2, and then times 7. So I've got a perfect square factor of 4 in there. So when I bring that perfect square factor of 4 out, I simplify it to a 2. Then I multiply the 2 and the 7 back together, and I get 14. But remember, there was already an 8 out in front, so I got to times it by the 8 that's there. And that ends up giving us 16 radical 14, and then the 84 is still in front. And this is our simplified solution.